Harpreet
Hello,
sir?
good morning to
I think 9:39 हो गए. We have to start the session.
yes, ma'am. Yes, ma'am. Yes, ma'am. So, good morning to all. So, today is the last day of the FDP, and we will now going to start the today's proceedings with the opening session of Dr. Nandan Kumar on technical textiles. Let me
हरप्रीत
introduce with the
सर,
today.
आपकी आवाज बहुत कम आ रही है.
Just a minute. Hello. Now I am audible.
Yes, sir.
Okay. So let me introduce our today's speaker, Dr. Nandan Kumar. Dr. Nandan Kumar has over 15 years of experience in the field of protective textiles. He did his bachelor in textile technology from NIT Jalandhar, followed by masters in advanced textiles and performance clothing, and PhD from University of Leeds, UK. During his PhD final year, he was one of the finalists in the NatWest Business Plan competition and one business plan competition organized by the University of Leeds, UK. This gave him motivation to move back to India and start his own venture, namely High Performance Textile Private Limited (HPT) in 2010. Dr. Nandan also received a grant from Ministry of Micro, Small and Medium Enterprise, Government of India, under the support of entrepreneur and managerial development of SMEs through incubators in 2012. HPTs is specialized in the spinning of technical composite yarns using para-aramid, meta-aramid, mod-acrylic, and other inherent flame-retardant fibers using innovative spinning technologies, and is a government-recognized one-star export house since 2017. Recently, company has also filed 3 patents in protective textiles and core spinning technique. So, Dr. Nandan, I am quite confident that our participants will definitely get a very useful insights on technical textiles from your wide and rich experience. And on the other hand, I must introduce my participants with you. My participants are highly qualified and highly experienced faculty members representing almost every states of the country. So without wasting much more time, I would like to request Dr. Nandan Kumar, please come forward and give insight on the application of technical textiles, especially in the today's era.
Thank you, sir.
Nandan.
Thank you, sir. Thank you very much. First of all, good morning to everyone. Just to let you know that Harpreet sir and myself, we are batchmates. We did our BTech together in 2003 batch. We passed out, and it's amazing after so many years. Again, it's just like we are talking in a class, in our classroom. Finally,
Yes.
So yeah, I mean, a brief introduction about myself, and I was going through lectures of Kothari sir, Chaudhary sir, Midda sir. It was fantastic, great experience, and even I was talking to Harpreet sir. What we are trying to achieve here. So I just want to say one thing, 10 years or 20 years before, it used to be technical textiles is a highly technical product. And design is a different thing now. 20 years before it was like that. When you are talking about bulletproof jacket, that is technical textiles, and fashion is your design side. But now in today's world, we need to understand, again, I'm talking about my experience, that technical products do need aesthetic look. Technical products do need those sort of like color combination. Because even if product is very good technically, it's performing, but if it's not appealing, or if it's not having good color combination, users are not interested in using it, even though it's going to protect them. So in today's world, we need to understand that technology and design both should be done together, and that's the reason I'm working with NIIFT Mumbai. I have a few friends in NIIFT Delhi, because technically we can develop something, but to make it commercially viable, we are looking for designers who can design these technical products, which I will show in the case study. Okay, so Harpreet sir, I'll need your help in sharing the presentation, and then I can explain each slide.
Okay, Dr. Nandan, I am always there.
Thank you, sir. Thank you. So, brief introduction about myself. Like sir said, I did my BTech, Masters, and PhD, and during final year, I was always interested in doing something different. Again, it's not like I'm not interested in research or academic world, but I was more interested in developing something which we can sell, which we can make a commercial very quickly. Okay, so you can see that last 2 years when my manufacturing was a little bit down because of Corona,
Can
I
you
gave
please
more
go
time
to the
on.
slideshow mode? Slideshow mode. That is from the top. Home, then insert, then design, then animation, then slideshow. Please go to the slideshow mode. Animation after the slideshow from the current slide.
So during this time, we have done a lot of development, which I see that there's a good commercial future. I'll go through a few of them as a case study. So is this, have you done the slideshow mode, sir? Because in mobile, I'm not able to see.
Yes, sir.
Okay, so
Sir, please click on the current slide, then it will be on slideshow mode. Please click on the current slideshow. Third one.
Now is it okay?
Not yet, sir.
But we did it on the slide mode now.
Sir, actually in other way, you can click on the bottom right corner, just left of the 45%, there is a cup signal. This one. Yes, no, this one. Yes, sir. Just click on that. No, third one. No, not that one. Third one.
Sir, what you can do, you can press Control and F5 simultaneously.
After 45%, there is a small icon. Just press it. On the left hand side of 45%, there is a small icon. Just click it. Yeah, click this.
I think we should proceed further. Is it visible now?
It is visible.
Yes.
हरप्रीत सर रहने दीजिए स्लाइड तो यहीं पे ठीक है
ठीक है
इट्स विजुअल
ठीक है ठीक है ठीक ओके ओवर टू डॉक्टर नंदन
Okay, sir. Thank you, sir. So, high performance textiles, basically, we are a yarn designing and manufacturing company. Last year also, I gave a talk to NIIFT Mohali, and there also I showed few developments. And then in today's discussion, I will show further work, what we have done on that, and new products, what we have developed. So these are the list of provisional patent applications which we have just filed, and we are working on them. And few of these products are under a non-disclosure agreement, so I won't be able to talk about that. But I can always discuss the products just to motivate researchers or students to think about new product development, and if they have any idea how they can take it forward to a commercial scale. Okay. And I really want to motivate them, like, rather than job seeker, let's try to become job creator, which is the need of our country. Because I'm in Panipat right now, and in Panipat, I can see a lot of uneducated people. They are doing very well in business, and in textile business, they are having export house and all these things, and having absolutely no idea about textiles, forget about technical textiles. So I really want to motivate students or researchers to consider this also as one option in future to set up their own manufacturing or services, like, Okay. So briefly about our company, we are a yarn designing and spinning company. So we have two setup, one in Panipat and one in Sonipat. Again, capacity wise, we are a very small company. We produce hardly 20 tons in a month, which is nothing for a spinning company. Most spinning companies, they produce maybe 100 tons a day. But 20 tons a month, when you are talking about aramid yarn, or you are talking about Dyneema or Spectra or HPP or composite yarn, then it's very difficult, because the average cost of our yarns are like $25 to $30 a kg. So developing products where you can promote 15 to 20 tons a month is not a bad volume for technical products, I'll show you a few examples of what exactly we do, how we are able to blend aramid with different fibers, what's the benefit, and why we do it, and how a researcher or designer can help us in future. These are our brand name: Aracore, Cut Pro, Flex, Save Splash, Anti-Stacks. So again, basically, we are very focused on yarns which can be used to develop protective clothing. Okay, because I know that definitely there is a good market in overseas for protective clothing, but soon it's going to be in India, because we are definitely going to become next manufacturing hub in next 5-10 years. You talk about automotive, you talk about any segment, India is going to become a manufacturing hub. And when we are going to become manufacturing hub, definitely our people will need protective clothing. Yesterday I was going through one tender of ONGC, where they have asked for impact resistant and cut resistant gloves. So it's a 3 years contract, and I know that hardly 1 or 2 companies can make that gloves, because you are talking about impact resistant, cut resistant, you are talking about HPP, and same example of Maruti. Now after 3 years of long struggle, now we are supplying our aramid gloves to Maruti India plant, which used to be imported or manufactured and sourced to them, but now we are able to supply them. So I can see good future of protective clothing in India because of our own manufacturing requirements or our own people. And accidents are very difficult. In my company, we have, like, say 25 people are working right now, and if there is a cut for any of the labor, if they get hand cut, or if they get cut in their hands or arms while working, it's a problem for me, because that guy cannot work for another 1 week, because he has to go home, he has to take rest, he has to go for medication. Just a simple hand cut can give a good amount of loss. So you can imagine big companies, if they are not giving cut resistant gloves or sleeves or work wear, it's a big problem for them, and that's what is going. It's happening now. Okay, so again, all these yarns are designed as per different requirement. So when we talk about Aracore, this is mainly based on aramid, both para-aramid or meta-aramid, which is fantastic. As you all know, that these are fantastic high temperature resistant fibers, and flex is based on high performance polyethylene, which is ultra high molecular weight polyethylene. Dyneema or Spectra is a good example. Again, Cut Pro, Save Splash, Anti-Stacks, all these are based on the different type of category. I'll explain what is flash fire, arc flash fire. Then you have anti-static requirements in the industry, why we need protection against electrostatic charges. So again, this is a list of end applications. So we are talking about flame retardant workwear, cut resistant clothing, bite resistant clothing, which is very compulsory in Europe or US in jails, where the chances of the jail personnel getting this problem of bites from the prisoners, because they don't have any weapon, but they bite from they bite, and they need a bite resistant clothing during time of patrolling. Stab resistant clothing, again, it's coming up in India also. Private security guards, they are asking for stab resistant clothing. Right control uniform, it's very immediate requirement for our paramilitary forces. What they are using right now is not comfortable and is not designed as per female paramilitary forces. Again, bikers uniform is an emerging area. We are already working with NIIFT Mumbai, and few MTech students are working on these bikers gloves and bikers uniform. Cut heat resistant gloves is a common one. Sleeves, balaclava, which is used under helmet of firefighters. Flame retardant socks, flame retardant undergarments. Again, it's very important for our defense people or firefighters. Firefighter suit, it's a very common product. Proximity suit, sewing threads. When we talk about stitching for FR workwear, it has to be using FR sewing thread. So aramid sewing threads are, we are selling good volume, and it's a good product. Braided ropes, this is a new development I'm doing. Using aramid yarns, we are making braided ropes and laces. So I'm sure this has got good future. When you talk about insulation of vibrating products, you need aramid ropes for that. Anti-vandal curtains, again, this is a good product for shopping malls or to reduce the weight of any automotive. Anti-vandal curtains are used. Even for home furnishing, you want certain curtains which cannot be cut manually. So this is again a very interesting product where high performance fibers are used. So if you go to the next slide, please. And again, you can see in the picture the molten metal. Molten metal hazard is a big problem these days because so far insurance cost, or if there was accident in any factory, the insurance cost or the awareness was not there. But now everyone is aware that if I'm working in a company, if something happens to me, then company is responsible, and so company should provide them the suitable workwear, so that they can work with full protection. Now, again, a very basic definition, which we all know, that technical textiles is mainly for their technical and performance properties rather than aesthetic or decorative characteristic. That's the definition. But I will say that now it's time we need to consider where both are combined or both can be combined. So you don't have to use very costly machines to manufacture technical textile. That's not true all the time. Yes, I mean, if you are going to weave aramid filament or Dyneema filament, definitely you will need a sophisticated weaving machine or warping looms. But when you talk about simple products, there are a lot of simple products like this one example which we have recently developed, and we are going to export these sleeves to USA also. You see, this knitting machine is very commonly available in Ludhiana. I'm sure you can buy these machines in 1 lakh rupees, okay? And this machine can make that fruit carry bags, which we have seen in market. And the same machine we are using to knit glass bags. So these are ECR glass bags. And in automotive, generally they put glass wool for sound and heat insulation. But when they put glass wool, they use polythene bag. Okay, they fill glass wool in a polythene bag, and that polythene bag is installed in automotive, and that polythene gets disappeared when the engine gets hot. So now in USA, soon the trend will come in India also. They don't want any polythene in the vehicles. So they want absolute zero polythene. So rather than using polythene, we are going to use this glass knitted bags, which will be high temperature resistant and very simple concept. Again, it's a good example of technical textiles, which can be done at a very low price with minimum investment. All you have to look into the requirement and definitely raw material, which raw material we should use, testing validation. So those sort of things are there. Again, simple examples are simple cotton gloves versus IFR gloves. I'll show one video also later on. When we are giving simple cotton gloves to our labor, that don't give any protection. If there's a small cut, that cotton gloves get cut through and their hands get damaged. So same FR gloves with anti-static properties. Simple socks versus cut resistant. Blanket, again, we did a small product development for RDSO 3 or 4 years before. We submitted a sample which was having aramid blended with wool, and Suresh Prabhu sir was the minister at that time. And the idea was to have one blanket in each compartment, so that someone can, during fire, someone can use that as a fire escape. I'm sure Railway is still working on that concept, and again, these sort of projects or products you can consider. These can be easily manufactured in India, and definitely when we talk about manufacturing in India, spinning cost, weaving cost, finishing cost, all these things are much lower as compared to overseas. So it makes sense to manufacture these products in India rather than importing finished blankets from overseas. Okay, and it's possible. Okay, again, I'll talk about this conductive cap, which is used for uniform cooling during chemotherapy sessions. These caps are used to reduce the hair loss. Again, it's a new area, and we have filed one patent, and we are working on this. I mean, all I'm trying to say that, that all these things are open research. And if you guys are, any one of you are interested in working on these projects, do send me email, and we can work on this. So this presentation, I just wanted to share what we are doing and how we can work together. A simple T-shirt versus cut resistant T-shirt. Again, there's a glass manufacturing company. They are looking for cut resistant T-shirt, because when they are handling glass, their shirts or trousers get cut. So we are working on developing complete T-shirt, which is cut resistant and which gives them protection while working. Sir, if you can take a yeah. Now this is a very good example when I talked about design and technology working together. This glove sample I have just received from UK. This is a simple glove which are used by night security guards. So if you see, the right side is our cut resistant fabric, which is manufactured using a Dyneema reinforced with glass and nylon to achieve higher cut level. So when you talk about ISO 13997 cut level, this will give you A4 or A5, easily. And we can further increase cut resistance level, or we can further play with the fabric. We can either increase height, make it more abrasion resistant, or we can make it even FR by using aramid in place of Dyneema. And the right side and the left side, you see the finished gloves having leather on palm. So now here the design part is coming into picture, and the fabric, although we can manufacture fabric, but we are working with garment companies where they can guide us how we can make the finished product. So if you can show the next slide, you'll see 3 types of gloves are here. So the first one is having a TPR on the back side, which gives protection against impact. And then you have a cut resistant layer, and then it's having leather on palm, or it can be nitrile or PU coated on palm to give chemical or water repellency. Okay, so you can see that technical textiles getting used in a product which should look good, because for a biker who is going to ride a BMW bike or Harley Davidson bike, he wants a very good gloves. So these designs can be used either for industrial gloves or even for bikers gloves. So if you can take to the next slide. Now, this is a very good example. I just wanted to share this case study with all of you. Even if product is very good, even if technically product works, and even if it's passing all requirements, there are times when workers or end users, they don't want to use it, although it's very good. And that's where I was coming from, that yellow glove, it's fantastic. Right now it's being used in automotive companies. You have Volkswagen or Wagon, or you have Maruti. They are using yellow gloves, which are reinforced with steel wire. But I know sooner or later they will switch to the left side one, which looks gray in color. Again, it's having aramid with steel wire with some nylon in it, and not yellow, because yellow gets dirty very quickly. Okay, if a labor is going to use these gloves for 3 or 4 days, you will see that yellow, even if you wash it, it's not going to be very appealing after a few days. Okay, so it gets dirty. So what we have done, we have blended nylon in different color to change the color of aramid. Because aramid being highly crystalline in nature, you cannot dye it in different color. There are dope dyed aramids available, but again, those are very costly. So to change color, you blend aramid with nylon, mod acrylic, or any other fibers with different color. You can get non-yellow color. Okay. So again, this case study can show you that although the product is technically very good, it may not be acceptable in longer run. So we have to keep an eye on the trend. We have to keep an eye that, okay, if I'm supplying this product today, maybe tomorrow we need to do some innovation. We need to make some changes so that increases the life of our product. Okay, rather than we are going to supply this because we were supplying this from last 10 years or 15 years, or it performs, so we don't need to change it. That's not the case. Okay, again, in gloves, 2 standards are very important. One is EN 388 and another one is EN 407. So EN 388 talks about abrasion, cut, tear, puncture, and there's the ISO cut test method, which is ISO 13997. Basically, it talks about force required to cut a fabric to 20 mm. Okay, so when we are talking about level E, that means 24.7 Newton is required to cut this fabric up to 20 mm. And when we talk about level F, it talks about 32.8 Newton force is required to cut the fabric up to 20 mm. So you can see that level F is better than level E. But when you want to increase the cut performance, you also don't want to compromise on dexterity. So you really want gloves to be very comfortable when you are wearing it. So in knitting, as you know, that you increase the gauge. So we have 15 gauge machine, we have 13 gauge machine, you have 18 gauge, 21 gauge. So higher gauge you go, the fabric becomes more comfortable. So the left one is your 15 gauge. It's more comfortable, and the cut level is slightly lower as compared to the yellow one, which is manufactured on 10 gauge glove knitting machine. Okay, so it's not only in the case of gloves. When you are developing or designing a product for any client, you need to understand, you need to do the proper risk study. Okay, example, if in assembly line, if a labor is working with small nuts and bolts for 8 to 10 hours in a shift, he's not looking for very high cut performance. He's looking for a good dexterity, because he wants to wear the gloves and he wants to work with a small nut and bolts, and he can do the assembling and everything properly. But at the same time, when a labor is working on metal sheet cutting, where he has to cut metal sheets throughout the day, he's looking for high cut performance and less dexterity. Okay, so based on the requirements, we should design our product so that, like, even small requirements of requirement for them should be taken care. Again, in both products, soon we will have to incorporate touch screen compatibility. Now, because what happens many times, you have to go and work on machine and work on the panel. So you have to. So we are working on making the fingertip screen compatible so that you can wear the gloves and you can still work on mobile or control panels. Okay. Now, in the next slide, this is just a brief introduction again about inherent flame retardant staple fibers. Basically, property of material whereby combustion is prevented, terminated, or inhibited following application of flaming or non-flaming source of ignition. That is the definition as per NFPA. So, when we talk about flame retardancy, it can be either achieved by using a variety of chemicals, phosphorus, bromine, and probenized chemicals are available in the market. But again, there the problem is after multiple washes, you don't know if the product is still FR or if it has become flammable. So that is the reason in few areas, inherent FR fibers are completely recommended. Example, if you see any tender of ONGC or IOCL or any oil and gas company, they clearly mention that the workwear should be manufactured using inherent flame retardant fibers. Okay, so I'll share some example of those fibers in next few slides. So here the basic requirement is shrinkage should be less. It should self-extinguish after removal from source, which I will show in next video also. Even after 100 washes, it's still flame retardant, and no dripping or melting observed. Again, the benefits, as we all know, reduction in insurance cost, less worker downtime, better employee morale, safety recognition in community. This is the Indian standard IS 11871, flammability and flame retardant resistance of textile fabrics. Sir, if you can run in that slide, there is a video. Can you try to run that video, sir? In the previous slide. Yeah, next one, please. Yeah, there's a video. That video is just showing basic 45-degree vertical flammability testing, where fire is, I think.
Is there any link of that video?
No, I think it has to be in slideshow mode. Then only it will run. You can just press Control F5.
Unable to do that.
Or in presentation mode.
Sir, go to the slideshow mode. The icon that is in the toolbar. It's number fifth from the left hand side. Home, insert, design, animation, then slideshow. Go to that first. Then go for slide showing from the current slide. From the current slide. Double click it, sir. Slideshow.
Sir, hit the button F5.
Not a problem, sir. Just you can pull that one only.
Dr. Nandan, in this there is video in this pic.
No, in this, sir, what I will say, you can just pull that one only.
This is showing as a pic, not as a video. Unable to
Okay,
click
no problem,
this.
sir. You can just pull that one up. No problem.
It is showing only a pic.
PNG.
It is a PNG file.
picture.
Alternately, you can send me the link of that video.
Sir, no problem. You can increase the. You can just bring that presentation. I will share this video separately. You know, you can
Okay.
forward to everyone. No
So
problem.
shall we move to the next slide?
Yeah, no problem, no problem. There are small videos which are easily available. Just I wanted to show how this 45-degree vertical flavor test is done.
The PPT already shared with the participants. The same
Yeah,
thing.
no problem.
Shall I move to the next slide?
Yes, please.
Is this okay?
So your screen is not visible. I think it's not on share mode right now.
Harpreet sir, please go to the shared screen mode.
Yes, I'm trying it.
Yes, sir.
Is this okay now?
Yes, sir, it is now okay.
From which slide we should?
Yes, sir.
Harpreet
Before
sir?
two slides before. Yeah.
Harpreet sir?
Hanji?
I have sent a picture where you can see how to make it presentation mode. You just click on presentation icon on the bottom bar. Then only you can it will be visible in the presentation mode, in the full screen mode.
Madam,
It is
actually,
already, I
now,
have sent. Yeah.
just being a coordinator, I have opened so many windows and I am doing so many things parallelly. If I go to
don't
the
worry, sir.
No, sir. This is already, it is visible on your screen, so you
Yes.
can do it. I think.
So shall we now proceed with this now?
Yes, sir.
Yes, sir.
It is
So-
okay, sir. It is okay. Visible. It is visible, sir. It's okay.
So what I have showed in previous slides, basic simple candle test, which anyone can do. If you use normal gloves, it burns in 5-6 seconds. Can you hear me? Harpreet sir, can you hear me?
Yes.
Yeah.
Sir, you are audible.
But when you blend same cotton with FR fibers such as modacrylic, aramid, or FR viscose, it makes the whole fabric inherent flame retardant. And definitely there is a price involved, but we need to understand we are talking about gloves or workwear which is giving no protection. At the same time, you have products which is going to give protection at the time of any accident. Okay. So this one example of again inherent flame retardant gloves. Again, the standard used is EN 407, which talks about vertical flammability, contact heat, convective heat, radiant heat, small amount of molten metal, and large amount of molten metal splashes. Again, we are very focused on manufacturing yarn, which are used for the glove industry. So every time I'm giving example of standards related to our product, but I'm sure you can Google standards like EN 11612, 611, which are related to workwear, or EN 469, which is for firefighter suits. So all these things are available on internet, and it's very important to know the standard, because you are going to talk to your overseas clients or researchers, and always they will talk about the standard. So as per which standard you are developing this product. Okay, so if global standards are there, go for that. If Indian standards are there, go for that. Just it's important to follow a standard when you are developing any product. Okay. Again, it's a very practical problem faced by us or any company who is into spinning of inherent flame retardant yarns. If you think about it, aramid, either you talk about meta-aramid, para-aramid, or FR viscose, mod acrylic, all these fibers are, unfortunately, these are not being manufactured in India right now. Maybe in future it will be. So right now we have to import these fibers from overseas. FR polyester is being manufactured by Reliance in India. FR polyester is available. But when you talk about all this testing and validation, current testing and all validations are done on the finished fabric, on the finished yarn or knitted or woven fabric. So imagine a small company like ours, we place order for aramid fiber. Say if I'm placing order for aramid fiber in January, it will take at least 60 days to reach to our factory. So you are talking about February, March, April, I'll have that fiber in factory. Then my production team is going to process it another 4 weeks. So you're talking about May till from the time you have done the purchase to get a exact test report that what happened, whether it's is having any problem, or because see, most of the time you are going to blend these fibers. So now we have a product where we are blending up to 40% of nylon, which is flammable, but 60% is aramid. Okay. So in future, what will happen? This blending will increase. And again, the reason for blending is very simple. Nylon is much cheaper than aramid. Okay. And nylon is more abrasion resistant than aramid. Okay. Aramid is more heat resistant than nylon. So to get the best out of both worlds, blending is comes into picture. Okay. So what we understood, that testing and validation is taking time.
Can I ask the question?
Sir, can we finish? Then we can discuss all these points. Question, I'll be very quick.
Yes, sir, this is related to the effort. That's what I'm asking. Maybe at the end.
We can. I know there must be a lot of questions. So
yes, we can take the.
Yeah. No
issues. I can take all questions. No problem.
Yeah. Thank you, sir.
So what we have thought about, or what we are working on, we are just trying to check the flammability after carding stage. Those who are from textile background, they will know that initial blow room carding is there. Then you have draw frame, speed frame, ring frame. So rather than waiting for the full yarn or fabric to be manufactured, we are working on developing a method where basic blended fibers can be tested. We can get an indicative test. This problem is very common. When you have a new fiber supplier, I don't want to say that Reliance FR polyester is having a problem, but 2 or 3 years before, when they started pallet line, one lot was failing, another lot was passing because of the variation in the phosphorus present in that. So we are working on a basic testing where a spinning company or any researcher can take the fiber, check basic indicative test, perform basic indicative test just after 1 or 2 stages, rather than just going for the full fabric stage and then doing the testing. Okay, so this will save a lot of time and money for manufacturers. So if you can go to the next slide. Again, these are very basic bench tests. We need to work on full lab scale test, a full test like flash fire, which I have showed in this presentation. Protection against flash fire, again, it's a very emerging area, and we are trying to work with IIT Roorkee to develop a basic kit where we can do testing for flash fire in India rather than sending samples to Europe and US for mannequin testing, or to study second-degree burn or third-degree burn. Okay, now you can see that simple standard fabric, it catches fire just after 4 seconds or 6 seconds in case of any accident where flash fire is involved. Sir, if you can go to the next slide. So what we did, this development we did almost 2 years before. We blended pre-ox with aramid to make a flare blanket. And although the product performs very well, commercially, I'm still working on getting it commercially launched because there's a manufacturing problem in this. When you process pre-ox in your mill, because it sheds a lot of powder, contamination issue is there. So what we understood that although this product is very well and very good, but during spinning of this fiber, it's a bit difficult to process because of the contamination issue. Okay, so again, it's a good example. Although product is technically very good and it can be commercially successful, but it's very important to understand how we can scale it up, or what are the problems we'll face when we are going to scale it up. Okay, so the problem what we are facing here is small mill, and when we try to run a pre-ox, it gives contamination issue to other fibers. Okay, again, we are looking for designers who can, rather than just a basic Batman type of fabric, he can design a good apron, or maybe protection for workers, and it should look good also. And the product is fantastic. It performs very well against molten metal also, and molten aluminum, and it's fantastic for flash fire protection. Okay, and there's no glass coming next to skin. Okay, again, this is one innovation what we have done, again based on our requirement. Rather than going for the complete twisted yarn, we have used roving yarn, and we have manufactured a yarn which is performing much better than ring spun yarns for thermal insulation, because it's having less twist. And even Kothari sir was explaining on that day, you have more air entrapped inside. It's better for insulation. So rather than yarn, we have roving, which is having less twist. And then to increase the strength, we have covered it with ring spun yarns afterwards. So you are getting a thick yarn, which is thermal insulation is fantastic. And commercially is very interesting, because my machines can produce these yarns much higher capacity than ring spun yarns. So example, if I'm able to produce 50 kg a day on ring spinning, these yarns I can produce 200 kg a day. Okay, so now you can see the product is technically good, as well as commercially it's very good, because you can produce huge quantity and small amount of time. Hence the price of this product will be much interesting, and it can be good commercial successful product in future. Okay. Now this is a very interesting concept. See, right now what's happening all over the world, they are talking about cut resistant gloves. You're talking about Dyneema, Kevlar, Aramid, all sorts of exotic fibers, high performance fibers. And one thing we are missing in India when we launch these products, that it's very costly, So my laborers, honestly, if I am paying them 10,000 rupees a month salary, how I'm going to give them 500 rupees pair gloves, to work every day? It's not possible. I cannot, and there are a lot of companies like mine who are struggling with this. We know that there are cut resistant gloves available. We know that all these gloves are available, but these are 300 rupees, 400 rupees, 200 rupees a pair. So I'm not going to give my 100 laborers all these gloves, which they are going to lose. And again, we have to, so all I'm trying to say that we need to work on protective gloves based on Indian requirement and based on Indian prices. Okay, so we have cotton gloves at the rate of 10 rupees per pair. and we have aramid gloves at the rate of 250 rupees a pair, it's not possible. So that's when we worked on an idea, and what we did, we took standard cotton gloves, and on the palm area or wherever we feel like the thumb and crotch area, we used aramid sewing thread for stitching just on the palm area. Okay, so what we are doing, we are using a traditional product, we are using a traditional cotton gloves which is easily available everywhere, but we are using high performance material on the palm area, where the more when a labor is working, this area is more coming in contact with the products. Okay, and so stitching can be done, and you can imagine if 55 to 60 gram a pair of aramid fiber is required for whole gloves, hardly 10 to 15 grams of sewing thread is required for stitching. Okay, now again, after stitching, because those protruding fibers are there which may create problem at the time of working, so what we have done, we have used water-based PU coating. Okay, so this water-based PU coating is just to give them not only oil and chemical repellency, but at the same time good protection. Again, I'm not saying that this can replace Dyneema or aramid gloves. I'm not saying that. This is completely different product, but we are working out a way how we can make gloves cut resistant or protective gloves at an domestic prices, so that majority of our organized and unorganized sectors, they can go for these gloves, and they can give these gloves to their laborers for protection. Again, it's a thought, same we can design other type of product which can be used by our manforce and which can be used in India at an interesting price, so that everyone is happy. Now, again, there's a lot of work required in this, because on gloves you need protection on both sides, on the palm side as well as on the back side. So when you are stitching, you are losing the dexterity of gloves, so it has to be balanced between both, and to make it commercially successful. Again, this was one requirement from our overseas client, where they are using gloves in the food industry, and imagine 1,000 people are working in a chicken processing unit, or 500 people are working in chicken processing unit, and everyone is using gloves. There are chances of gloves getting in the food packed, or so the idea was to find out a way how we can detect these gloves. So what we have done, we have used tungsten in the core, and tungsten is very dense metal, and we have made a yarn which is having tungsten in core, and we made a gloves, and when we put in X-ray, you can see the metal, you can see that it's there. So we have compared both without wire and without tungsten and with tungsten. And again, it's a very good concept, because these gloves can be washed so many times, and still it can be detected under X-rays. Okay, there could be a lot of application for this product, and again, there's no coating involved. Like right now, barium sulfate is coated on textile to make it X-ray detectable, or in gauges and all these things. So this is completely inherent, and again, this could be interesting product in future. And we can make these yarns in different texts, different denier. We can use different types of tungsten. Here we have used 30 micron, we can use 20 micron, 40 micron, 50 micron. So we can optimize the yarn and fabric based on the requirement. Okay. So again, same based on our core spinning, rather than using tungsten, here we have used SS wires, 30 micron, very fine stainless steel wire. And we tried making gloves and even cap. And our plan is to get, our requirement was to get uniform cooling. Again, I won't be able to disclose much of this concept because we have signed one agreement with a company, but I can share that this concept is fantastic, where you have a washable textile, which is good thermal conductive throughout the product. So you are getting uniform cooling throughout the region, whether it's head or whether it's arm area. So again, it's a fantastic product, and it's not only we can do sampling, we can immediately scale up the production. We can easily produce these yarns up to 5 tons or 6 tons a month. That is most important, because few times if you can make sample but you cannot scale it up, again it's a problem, because scaling it up is important to bring the cost down. Okay, so again, this one area is very interesting, and we are looking for designers or researchers to work in this field and to work with us. If you can go to the next slide, sir. Again, last time also we discussed about this. Last year also, where I was giving presentation, I talked about this concept. Now, what we have done, we have developed our own sample. This complete set is manufactured by us. We have made 2 samples. Basically, outer layer is again ultra high molecular weight polyethylene with nylon. It's a 500 GSM fabric, which gives cut protection of A7, which is very high level. Then it has a middle layer is aramid and steel wire knitted mesh, and warp knitted aramid roving to get the cushion effect to give protection against impact. And we are working on getting it tested as per our requirement of Home Ministry or even for overseas. And we are working on making it more lightweight so that it could be interesting for our paramilitary forces or even for private security forces. Again, it's a very good area where we can optimize based on our own requirement and blend some high performance fibers with our own fibers, so that, like, to make it cost effective as well. Okay. Sir, if you can go to the next slide, please. Again, this is there was a small video even I put out in YouTube or on my LinkedIn profile. This video won't work here, but it's just to show that we have a conductive yarn, which is basically 20% stainless steel fiber and 80% polyester or polypropylene based on requirement. Yesterday Chaudhary sir was talking about electronic textiles, and this is one good example that we can manufacture yarn. And right now we are making 28 English count, but we can make from 10 NE to 60-70 NE. And that can be conductive in nature, and that can be embroidered, that can be stitched, and a variety of applications can be developed using these raw materials. Again, very fantastic product for researchers or designers to look into, and we can support on the raw material side. Okay. So if you can go to the next slide, sir. Again, this is a range of, you can see that the surface resistance requirement for a conductive, dissipative, and insulative product. So we are getting resistance in the range of conductive. We can also, we have a yarn which is giving 10 ohm or 20 ohm. So, we have a highly conductive yarns. At the same time, we have dissipative yarns, which are based on carbon-based anti-static fiber, which can work as an anti-static fiber rather than conductive. So again, a very huge area where a lot of work needs to be done. Again, based on our own requirement in India. If a development is done in overseas, and if you import that product, that becomes very costly, and again, it cannot be supplied to many people in India. But yeah, if we can manufacture something in India using the properties, definitely it can be commercially interesting. That's again interest of our company, that we want to make something which is commercially interesting as well as technically important. So if you go to the next slide, please. Yeah, this is one important area which will definitely become a problem in future. We are talking about electronic textiles, and we are talking about conductive yarns, we are talking about metallic yarns, but what are we going to do with the waste of these yarns? Okay, because as you know, Panipat is having a big recycling plants. Panipat is known as a recycling plant of India. We have here a lot of big units. They are recycling clothes, and they are making yarn out of that. Okay, now we cannot do that with these metallic waste, because it's having conductive steel wire inside. The moment you put this in garnetting machine or carding machine, there will be a big explosion or fire because of conductive nature. So, I've just got some idea, and again, I'm looking for researchers who would like to work on this, because trust me, it is already a big problem we have few clients in Malaysia. They are very big glove companies, and they are telling me that they have at least 2 to 3 container load of gloves waste. Okay, and they cannot do anything because it's having steel wire inside, and you cannot just process those gloves like a traditional textile because it's conductive in nature. So it's going into landfill. Okay, so all these gloves having steel wire inside, all these are going into landfill in today's world. Okay, because it's very difficult, or I'm yet to find out a company who is recycling these metallic yarns. Okay, or I'm yet to find out someone like who has done something where we can recycle metallic yarns and we can take the fibers out or steel wire out, like except burning. I mean, many companies I know, they burn and then they take the steel wire out, but again, that is not a good way of recycling. So what we have done, if you take the next slide, what we have done, although it's a very basic method, we have tried to make balls, or we have tried to make different structure out of these waste and coat it with water-based PU. Okay, so what we are trying to get, different type of structure which is filled of these high-performance metallic waste. Okay, so imagine you have a circular ball which is puncture resistant, or you have a long thread rope-like structure which can be designed to wrap around your neck for puncture resistant or stab resistance. So, I mean, a lot of ideas can be developed where, like, these waste can be made, can be converted into that shape, and then coated with PU or silicon, like, and can be used as a new product. Maybe, I mean, I'm sure this can give very good EMF shielding as well. We need to do testing because, you are having all these metal steel wires inside, and the structure is only coated with water-based PU or silicon or anything, So we have filed one application, and we are working on this. Again, it's a very interesting and new area. And finally, I'd like to summarize with few of my thoughts. And again, this is just my opinion based on my last 10 years of experience, where we tried to develop and manufacture and sell, So first of all, let's understand the important stages in product development. It's very important to understand what's the requirement, and the more information you have, better it is. Example, if a company is asking you to develop a product and there is no legislation for that in India. Example, I'm just giving example. If a company is saying that I want white blood cells filter, and we don't have any legislation in India that that you have to filter out white blood cells before transfusion, then it's going to be a waste of time, because even if you develop something, legislation is not there. Okay, so maybe you need to look into all these aspects, like that why you are going to do this development, what are the issues, try to get all those information, and then you start working on the solution. Okay. Again, the next important part is standards for product approval. So once you have developed, you need to know what are the standards. You are going to get it tested. Sample prototype. Again, we all know the first stage. But at the same time, you should always consider hurdles for bulk production. Example, you have imported a fiber which is working out very well, but there is a 40% import duty. So you need to understand, that when you are going to do bulk trial, you'll have to add 40% import duty also. Okay, so all these things you need to understand when you are making sample prototype. What will happen, what are the hurdles when you are going for bulk production, whether it's a process control, whether it's a raw material supply chain, or whether it's a skilled manpower, So the fantastic example I'll give you, although we are able to do PU dipping in Panipat, I am not able to find skilled people who can work on this bulk scale, So I'm considering bringing a few people from Sri Lanka, who can teach our guys on the glove dipping. Okay, although technically we can do it, but you're talking about 40 to 50,000 pairs of gloves being dipped into PU, and same quality. So skill set is a problem in this region. Okay, so it's important to understand all these things at the time of prototyping itself. Testing validation, again, we all know it's important. Protecting IP, as you can see, we have filed many applications, and it helps, especially when you are looking into future. And I know that next 5 or 10 years, IP is going to be very important part in India. There will be litigations where, like, people having IP will win. So it's important aspect. A bulk manufacturing trial. Again, you need to look for partners who can do manufacturing for you, or if you can manufacture, that's also a good idea. Now, challenges. I try my best to motivate students, researchers to become job creator. And it's not like that looking for job is a bad idea. It's not like that. Always, we all need experience. Even I was doing job before. But we should keep in mind that setting up your own venture should also be an option. You should not say, no, I'm not going to do that. You should think about that. Maybe now, after 5 years, 10 years, because we already are, and we will be future manufacturing hub. So you have plenty of manpower, which you can, if you can train properly, it can be a very good asset at an interesting price. Seed funding support for startup companies. In UK, we participated in a lot of business plan competition that gave us motivation. Here also in India, I really want to do that. Startup funding support. If we can help with students who are interested in setting up their business with some funding. Blending and spinning off. Again, I'm talking about my own area. That when you talk about high performance fibers, especially staple fiber, blending and spinning is still a problem for research institutes. It's very difficult to get 50 kg or 100 kg of yarns made by any government institution. It's very difficult. It takes time. Again, no report or research is conducted if trial fails. The same thing I told last year when I was giving presentation to Ministry of Textiles, and Secretary Sir, I think Kapoor Sir was there. I told them same thing, and I think they are in process of setting up another lab in Hyderabad or something where they are going to focus on technical textiles. Need to develop facility to process long staple performance fibers. Again, it has to do with the textile engineering side. Sometimes interest is only to publish a paper rather than developing a commercially successful product. Again, I have explained that if you see that commercially or bulk trial is going to be a problem, so prototyping should be done keeping all these things in mind. Again, publishing a paper is also a very important aspect because that's where other researchers, they know what has been done. Again, this point I would like to bring again through this platform, that a lot of institutes, they have a good quantity of good machines available, whether it's IITs, whether it's Atira, Nitra, Betra, they have good machines available, but it's very difficult to find out, it's very difficult to lease them out. Say example, if they have a needle punch line and if we want to run some trial for 3 weeks or 4 weeks time, there is no model available where a small company like us can lease out those machines for 2 weeks or 3 weeks to take variety of trials before going for big investment. Okay, so again, this thing we should jointly try to convey message to Ministry of Textiles, like that whatever kits are available, it should be easily accessible to all researchers, whether they are from institute or whether they are from companies. Definitely, they should charge them. They should keep a deposit. But model should be simple, that you take the material, you use the machine, you take the trial, and then you focus on your development. Okay. So I'd like to conclude my talk with this one. Thank
now
you
we
so
can
much.
have now we can have the question answer session. In case anybody have a query, then you can ask, please.
Yeah, Dr. Nandan.
Hello, sir.
Yeah, Dr. Nandan.
Yes, sir, I can hear you.
Yeah, this is Dr. Praveen OK from Ichalkaranji, DKT Ichalkaranji, sir.
Hello, sir. Hello.
Yeah, I want to ask, like the FR fabrics you have talked about, maybe the technical textile, that fabric which are produced from the aramide, and the one you have talked about the polyester. So with that, which is having that oxygen limiting index, I mean, the polyester is good or the
Hello,
aramide
sir.
is good?
Yeah.
Yeah. So have you done some kind of the comparison or the studies which you've come across?
Sir, voice was not there. Let me say, you are saying that aramid is good or polyester is good?
Polyester, as per the FR fabrics are concerned.
Harpreet sir, can you help me with the question, please? I'm not able to.
Am I audible, sir?
Hanji sir, can you repeat the question, please?
Yeah, I'm asking like aramide is good for the
If I'm correct, you are asking
FR
about
or the
aramid versus
polyester is
FR
good?
polyester, if I'm correct.
Yes, sir. Yes.
Hello, can you hear me, sir?
Hanji, Dr. Nandan, please.
Nandan sir, am I audible?
Sir, I'm so sorry, I'm not able to. Harpreet sir?
Dr. Please, can you write it in the chat box? What is your answer?
Can you hear me?
Yes, Dr. Nandan, yes.
Yeah, particularly I'm asking related to the comparison of the aramide and the polyester.
And what is your exact question?
Yes, sir. I'm asking related to the aramide or the
Yes, sir. Now,
polyester,
yes.
which will be the better for the FR.
I think it should be it will be the aramide. It will be aramide.
Sir, this is Selva Kumar. Sir, am I audible?
Yes, yes, Salvaji.
Sir, actually, that you have
Harpreet sir,
presented
can
about
you
that.
hear?
Sir, the conductive yarns, you talked about that. So, whether it is possible to get soldered by the PCB or the conductive yarns can able to get soldered by over the PCB?
Harpreet sir, can you hear me?
Dr. Nandan, yes, you are audible.
Sir, am I audible to you?
Hello.
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 Hanji, that's a बोलिए please. Dr. Nandan.
Hello.
Just a minute. Dr. Nandan, please you continue. You are audible. Dr. Nandan. There is something networking errors. Dr. Nandan just rejoining the meeting room. Just wait for a second, please.
Sir, can you hear me?
Yes, Dr. Sam, you are audible. Please continue.
Okay. Yeah. So sorry. I got the question like aramid or FR polyester, which one is best for workwear? If I'm correct, that's the question. So let me share my view. FR polyester is good for home furnishing, but it needs more research for workwear application. Because a few times I have seen FR polyester getting if you burn it, it melts and it drips, which is the basic definition of FR, that it should not drip or it should not melt. I know Railways is using FR polyester based curtains in trains, but I think a lot of study is required. I think monoclinic cotton is best alternative for workwear, for low cost workwear, or aramid blended with FR viscose is fantastic, which is used by Indian Navy, or which is even used by defense. A lot of aramid FR viscose blended workwears are being used, 180 GSM, 220 GSM. It's a fantastic product, and FR polyester needs more research for workwear applications. Okay. I hope that answers. Again, it's based on my experience. And sir, can you help me with any other questions?
Yes. The other question is, in the case of gloves, which constitutes blister as well as aramid fires and later coating with PU. So in this case, what about the adhesivity of PU with both of the fibers, that is polyester and aramid?
No, I mean, see, coating with aramid is not a problem. Again, for workwear, definitely aramid is more stable. If you do a simple heat shrinkage test, you keep both fibers at, like, say, 200 degrees centigrade for 5 minutes or 10 minutes, you will see the shrinkage in FR polyester, whereas the stability in aramid. So definitely, aramid is better choice for gloves. Even the strength after heat treatment, the residual strength of aramid is much better than FR polyester. And when you are going to make when you are going to do reinforcement steel wire, which is low elongation material, you need a low elongation fiber, which is again aramid. Otherwise, what will happen? The steel wire will pop out if you are making a core yarn using polyester and steel wire, and that steel wire will come in contact with skin, which is not good for any labor. So you really want steel wire to stay inside. Again, that's the reason you have low elongation fibers like Dyneema or aramid being used in hand protection. Okay, I hope that answers the question. Adhesivity, like, no, see, we have to like Dyneema, it's hydrophobic in nature. It's very difficult to coat Dyneema or HPP with water-based PU, or so certain type of treatment is required. With aramid, mostly latex is used for dipping. And so yeah, based on the raw material, R&D is required for all this coating. The recent trend is silicon coating, although silicon is very costly, but still I am seeing few gloves coming in market which is having silicon coating, which is fantastic. It's very good. It's very good and very durable, as well as silicon is very good high heat resistance. So yeah, based on the requirement, study is required, to develop the product.
So the next question is Mr. of Selva Kumar. Selva Kumar, can you come on the screen, please?
Sir, am I audible, sir?
Yes, you are audible.
Sir, actually, that your presentation is so good, sir, and I think with the background of all your studies, and you initiated many products with the low cost in India, sir. It is a really welcomed one, actually. We are also, yeah. I am also having some questions on this. You have told that the conductive yarns are nowadays it is used for electronic textiles, smart textiles, we can say. So in this case, the flexibility of the PCB is very important. Then usually that for the hard embedded PCBs, whether it is possible to use these yarns for making interconnections for some applications. That's my question.
Sir, see, right now, what I was thinking, I was thinking that maybe we can use embroidery, which is very smart and which is durable. So even Professor Jana at NIIFT Delhi, he's working on that. He used our yarn to do embroidery and so yarn is available now. It's time we need to play with it, So because we really need to work with our instrumentation friends, electronic friends. We need to work with our I don't know, printing guys. So it will never happen that one company can do all. So we really need to work together as an intercompany or interdisciplinary research, where you have designer, where you have electronic guys, where you have a guys who are good with circuits or programming, So the basic component is available. What we can achieve, we can play with the percentage of conductive component in our yarn. We can play with the variety of copper coated wire, silver coated wire. We have tungsten, we have stainless steel in different grade, 316, 314. We have variety of material from 30 micron to 70 micron. Then we can spin it with different types of fiber, which is very difficult. We can make the yarn of 60 count, 70 count, 40 count. So all these varieties available now. But when you are talking about making an antenna, or we are talking about making a circuit, definitely we need help for some joint work, where we can optimize our product, So I hope that answers your query,
Yes, sir. Yes, sir. You rightly pointed out. Without that electronic experts, we cannot move on to the development.
Sometimes that part is very frustrating for small companies like us, sir. We try to approach big organizations and they don't listen to us because we are not Tata, we are not Reliance, and it becomes so difficult. You have something, and I know our product is of global nature. If you show my gloves to USA or even in Europe, they won't say it's rubbish or it's Indian. They won't say that. They will say it's a ISO 13997, which is the global standard. But creating those things, and sometimes we struggle in finding researchers or big institutes. They don't want to work because we cannot finance, and obviously we won't get funds.
Yes,
so anyway, I know things will change. We are now in touch with few venture capitalists. They have shown interest, and that's the reason. Probably next 1 year, another 1 year, I'll file more patents. I'll keep on filing more patents, so that one day someone will take interest, and we will at least find a good team to work to develop these products.
Yes, sir. Exactly, sir. Thank you so much, sir. I think this is really inspiration talk. Thank you so much.
No, thank you, sir. Thank you, sir. Thank you, sir.
So I have a question. This is Sapna
Yes,
from NIIFT Mohali. As you talk about, since your presentation was going on, I was thinking about the next two wearable skin garments, which can be incompatible with the FR fabric. So what kind of construction, or what kind of ingredients is being used as a raw material for designing these types of next to wear skin garment? Because with this particular garment, we are looking forward for comfort aspect as well.
Yeah.
Because it is, say for example, if we are using the fire retardant fabric for firefighters or maybe for our soldiers, so it is not the always instance of fire is not there.
Yeah.
So I just wanted to clarify that what kind of design constructions or the raw materials that you would suggest for such type of garment?
Ma'am, I mean, see, we have, I love cotton. Cotton is the best fiber for us. It's fantastic next to skin. We do have some short resistant yarn which is manufactured using cotton. But if I try to sell it, I won't be able to sell it, because it's not having aramid in it, So my suggestion is let's try to work on double layered fabric, where outer layer is your maybe high performance fiber, and the inner layer is your cotton or cellulosic fibers, which can be next to skin. So all these things are possible. You talk about we have a yarn which is cotton outside, whereas it's reinforced with Dyneema inside. It's a fantastic yarn because the core is there for protection and outside layer is there for comfort. Okay. So again, case-to-case studies, if you have some application in mind and if you think that, okay, this is what we are going to develop, and for that, this is what we are going to require for in our raw material. So we can work out a certain type of yarn, maybe few kgs, so that you can start working on those yarns. Or we do have some sample knitting machines, 10 gauge, 13 gauge, 15 gauge. We can make small samples. And I think that way we can take it forward. I hope I have given some clarity.
Yes, of course. Thank you so much. One more question is there.
Yeah.
As far as this chemical protective workwear is considered, so how this fire retardancy as well as this chemical contamination go side by side?
I mean, in FR suits, you always have a semi-permeable membrane inside, which is giving protection from these chemicals, which gets penetrated inside. Even example, we have a sail splash fabric, which is coated using neoprene on one side, just to give some repellency. So I mean, definitely FR proximity suit or firefighter suits are multiple layered structures, and each layer is there for certain application, certain requirement. So yeah, inner layer is definitely poral membranes are there, which are breathable. At the same time, it gives protection against liquid. But again, a new research area, even we are working with one researcher from a mechanical department in Madhya Pradesh. We are trying to work on protection against steam, because steam, high pressurized steam, it passes through fabric or even coated fabric very quickly, and burn from steam is a very dangerous one. So we are working on developing some structure which can give some protection against hot steam, for power factor or steam generator, or people who are involved with steam on day-to-day basis. So yes, a lot of research is required to make some product which can be commercially interesting in India, which can be sold at a good price, and which can be used by our end users.
So, okay, as far as layered combination is considered, especially I'm talking about this chemical protective layers. So we should prefer to go for FR as the first layer, and then in subsequent layers we can incorporate that chemical protection, or chemical protection layer at the first, as a first layer, outermost side, and then rest of the things in the subsequent layers. What would be preferred?
I think outside layer if you are going for single layered workwear, if you are going to design something for a low risk area, okay, where it's a uniform, where a person is going to wear in and out, so you can consider PTFE coated aramid fabric. So you have a fabric is coated, it's a single layered uniform. So yeah, it can be outside.
Okay, and one last question, sir.
Yeah.
How we can ensure this? Whether we can ensure the reusability of the FR fabric once it is exposed to the flame? It's because there are a lot of combinations that we are using to develop the FR fabrics. In case as you said, that a lot of standards are there, and we should take care of that. It should not decompose or prepare any hard plastic char kind of things.
Yeah.
So in that case, can we go for the reusability once it is exposed to the fire?
No, after once you are exposed to the fire, like you cannot use this entirely. Definitely, you can recycle a part of that. Example: bulletproof jackets. If it's shot one time, it has to be discarded and reused or recycled. Same with the fire. It needs proper evaluation that what sort of accident was there, how it was, which area was damaged, and definitely all these fabrics, if there is no steel wire inside, it can be recycled. In market, recycled aramid fibers are available. That's how these fibers are coming into picture, because all these work wears are recycled, shredded into fiber, and then they are sold in market as a recycled meta aramid or recycled para aramid at a lower price. And so yeah, it can be recycled, but not in the same form.
Okay. Thank you so much, sir. Thank you so much.
Thank you. Welcome.
Dr. Nandan, I got a chance to listen you first time.
Oh, thank you.
And after hearing, I must say that Dr. Nandan, you are a textile engineer, a researcher and innovator, successful entrepreneur, motivator, and a good human being who always keen to help others.
Thank you, sir. Thank you, sir.
Such
I'll try my best to help.
a unique blend of multiple qualities, which are rare to find others in everyone.
Thank you, sir. Still trying my best to motivate and to help other researchers. I circulated one leaflet that anyone is looking for aramid fibers up to 2 or 3 kg, let me know. I'll give you for free, so that you don't have to struggle for these fibers. Keep asking big companies, give a sample, give a sample. So if anyone working on aramid, meta aramid, mod acrylic, glass, ECR glass, tungsten, you name it, 400 denier para-aramid filament, I have it. I'm trying to work on a library of fibers where a researcher can take 500 gram or 1 kg and play with it. It's time we start playing with these fibers.
Very good.
I really liked one guy from South India. I gave him pre-ox fiber and I told him, what are you going to do? He said, sir, I will use charkha to make yarn out of this. I was so happy. Like, imagine he's going to use charkha to make 20 meters of yarn, and that 20 meters of yarn, he's going to make some fabric and do the testing. See, no one can stop these type of people, who are going to use charkha to make aramid yarn or pre-ox yarn, because everyone knows that you can't card 40, 50 kg, less than 50 kg or 100 kg of aramid. For carding machine, minimum is 50 to 100 kg, and 100 kg will cost you what, 3 to 4 lakh rupees. $30 a kg. So, you see, that's what we need. We really need to go back to 100 years old technology to make yarn out of these performance fibers, so that you can make your own A4 size sample, and you are not dependent on any research institute to make your own sample. You make the sample, you do the testing, and you show the results. Then you get funding. So that's the way forward. That's the way forward. So please circulate my slides, and I will forward a separate slide where I have given all the list of fibers which I am having, and I don't mind supplying 500 kg, 1 kg, up to 3 kg, no problem. More than 3 kg, definitely you need to buy.
Sir, am I audible to you, Nandan Kumar, sir?
Yes, ma'am. Yes.
Interested to get the waste of that tungsten coated waste yarn that we for certain special applications.
Yeah,
The
no
waste,
problem.
is it possible to get
Yeah,
some portions of it, so
Yeah,
that
yeah,
I can
I will.
have a different kind of application with those waste material?
No problem, ma'am. Yeah, you just pass on your details to Harpreet sir. I'll check it and I'll courier it. No problem.
Sure.
Okay.
Thank you.
Okay.
Now, just a minute, Dr. Nandan. I would like to request our principal to present a vote of thanks for such an insightful session. Over to Dr. Poonam.
Thank you.
Principal NIIFT and Chief Coordinator Online FDP.
Thank you, Harpreet. A very good morning to everybody, and a special good morning to Dr. Nandan. Dr. Nandan, it was indeed wonderful hearing you out, even if I was traveling, but I have been traveling through your lecture all through, and it was so wonderful. And the beauty that I could take out of your lecture was that no design is possible until and unless we learn to amalgamate with each other. And that is very, very truly said. because until and unless aesthetics and technicality join hands together, the end product does not become user friendly and act for the user. So perhaps that's what was the catch of your talk, and your insightfulness, the way you have been able to explain the fibers to the people, the type of fabrics that you've been talking, since I've heard you earlier as well in the last time, especially the last time when you took out time for our Mohali candidate. And at that time, we were really grateful to Bharti for having done that for us. So thank you so much. And we keep on looking forward to be having you with us every time. Thank you, Dr. Nandan. Thank you.
Thank you, ma'am. Thank you. Thank you. Thank you.
Yeah.
Thank you, Dr. Nandan, once again for sparing time for all of us.
Thank you.
Now,
Thank you so much. Have a nice day, everyone.
Thank you.
Bye.
Our next session will start at 12 on fabric innovations. I'm sure that session will be also be very insightful. So kindly rejoin us at 12 for the next session on fabric innovations by Mr. Praveen from GAG Consultants. Thanks to all for patient hearing.
Thank you.